The next problem statement is to sort the given list of integers in ascending order using quick sort algorithm. So as part of this code in the quick sort, so I am going to use the header file #include stdio.h void quick sort. So I am using the void function with parameters void qsort of int array, void qsort of int array. Next I am going to give int the first comma int last, the first and last index. Next int main. So within this I am going to initialize an array of some size, comma I for iteration and n to take the number of elements in the array. So first I am requesting the user to enter the size of array or the number of elements which I want to take in the scanf %d address of n. scanf %d address of n. Now here we need to ask user to input the elements, enter the elements, the given array. Now here this is a one-dimensional array for I is equal to 0, I less than n, I plus plus. So till the size is satisfied, we are going to input the element address of. So where we are going to store the elements in address of, what is the array? Array of I. Array of I. Now let me call the function. So the first one we have written, this is function declaration, and we are going to write now function call or calling function. The qsort of, so we need to pass the array followed by the starting element index and the last element index is n-1. The last element index is n-1. So after this we are printing the sorted element are. So we need to print the sorted elements. In order to print, we require one for loop. For I equal to 0, I less than the given number of elements, I plus plus. So here we are going to printf %d/t. So the sorted elements, they are there in the array. So after performing the logic, we are going to print them. Printf, the new line, return 0. So this is how we are going to write our driver code, in which we are going to ask the user to give the size and to input the different elements, and we are just calling a function, and here we need to write the definition for this function. So after performing the all logic, we are printing the sorted elements. Now we are going to write the function definition for qsort. Void qsort of int array, comma int, what is the first? Int last. So first and last index. Int array, int first, int last. Now here I require some of the identifiers, int I, j, and pivot element, and next one temporary variable. So these are the identifiers which I require as part of this code, the logic part. So first I am checking with the condition. If first is less than last, if first is less than last, then pivot value equal to first, then pivot value equal to first, and I value is equal to first, I value equal to first, j value equal to last, j value equal to last. So here I am going to write a while loop while I less than j, while I less than j. So within this I am using one more while loop to check the elements, to compare and process the sorting logic, while array of I is less than or equal to array of the pivot element and I less than last, So till this condition satisfied, this while loop should be executed. And here what we are doing is we are just incrementing the I value by 1. Here we are incrementing I value by 1. If this is the case, we are just incrementing I value by 1. The next while loop, because as part of the quick sort, so here according to the given logic, we need to trace both from left to right and right to left. So this is the for tracing from right to left, ARR of j is greater than ARR of pivot. ARR of j is greater than ARR of pivot, then the j value should be decremented by 1, j minus, left hand side and right side. So these both are the loops which we are using for tracing left and right. And next, once the tracing is been properly done, now we are going to write the actual logic for swapping. If I is less than j, then we need to store those values in some temporary variable. We are going to store that in some temporary variable, that is temp equal to array of I, Next, array of I, now this value will be empty, where we are going to store temp. In array of I, we are going to store array of j. Same swapping logic. This is similar to the swapping logic. Array of j. Next, in array of j, we are going to store the temp value. Array of j, we are going to store the temp value. So this is the logic for swapping. Next, after this, after completing of this while loop, the external while loop, now here we need to store temp equal to what is the array of pivot element. In array of pivot element, we are going to store array of j. Next, in array of j, we are going to store the temp value, and next we are going to call the recursive call, that is left recursion and right recursion over here, that is q sort of array comma. So what is the first and j minus 1, first and j minus 1. The next one is q sort of array comma j plus 1 comma last. So this is for left recursion, and this is for right recursion, left recursion and right recursion. So this is how we are going to write the logic, the function definition for quick sort. Now let me execute this code and check whether the elements are getting sorted order or not. So first let me give the size of the array. The size of the array is, let me take 8 elements. So let me take these elements in a random. 5, 8, 2, 1, 7, 6, 4, 12. So these are the elements. Now all these elements, they are in the sorted order. 1, 2, 4, 5, 6, 7, 8 and 12. This is how we can get the elements in the sorted order. If you process the internal steps, you can clearly understand how the elements are getting in the sorted order according to the implementation of quicksort algorithm.